In this video I will discuss briefly how to use this inspect. Okay, inspect GUI for Idarc 2D. Okay, first let us briefly explain me about the problem. Okay, see, this is the framed structure. This is the frame structure. This is 2-story and 2-bay frame structure. You can see here. First I want to tell some basic terms. What is mean by column lines? Column line is nothing but, you can see, this is j is equal to 1, this is one column line, and j is equal to 2, this is one column line, and j is equal to 3, this is one column line. That is, this first grid, this grid is one column line, and another grid is, this grid is another column line, and this third grid is another column line. Okay, at base it is 0, and at first story we can designate as story level as 1, and second story as second. Okay, 2, and these are green yellow boxes are designated as columns. Okay, I have given numbering. The numbering will go like this. Okay, 1 2 3 4 5 6. There are 6 columns, and similarly you can see round. Okay, in circle you can see this circle denotes the beams. Okay, first beam, second beam, third beam, and fourth beam. There are 4 beams. Okay, there are 4 beams. And what is this 1 2 3 means? In order to connect the beams, we have to follow this procedure, this style. That is left side and right side. What is the left side unit here? 1 for this one first beam. Similarly for second beam. Okay, for second beam 2 3. Okay, you will get and you will understand while I am explaining. Okay, and suppose whenever earthquake hits this building, let us say horizontally. Okay, horizontally, let us say earthquake hits the building. Okay, it's the building like this, something like this. Okay, something earthquake ground motion hits, then what will happen to this frame, 2D frame of the building? Okay, just open your inspect. Okay, open your inspect. While opening, your inspect looks like this. After opening, your inspect look like this. Then after next, then number of stories. The number of stories is obviously in this case is 2. Okay, then number of identical frames is 1, that is 1 frame. Then number of different concrete material 1, and because we are using M30 grade or something like that, you can use any grade. Okay, if you are using more number of grades, you can put there too. And number of different type steel reinforcement property sets. I am using only 500 F5 500. Okay, if you want to include the P delta effects, you can tick this. You can select whether this or this. Okay, then next. Okay, then next. Then after you have to here beam element types and beam data, element data. First element types. Number of column types. There are only one column type, that is same size and everything. Okay, and number of beam types. In this frame I have taken only one type. Okay, the number of columns, how many? There are 6 number of columns, so you can enter there 6, and number of beams is obviously like 4. Okay, 4. Then after you select this produces Idarc generated envelopes for at least one element. Okay, you tick this first one. Then you can select whether this or this depending upon your units. Okay, I have taken this kilonewton. Okay, then number of types of hysteresis rules depending upon your problem. You can take 2 or 1 3 4 5, whatever it may be. Okay, then elevation of stories. Okay, then you have to enter the story elevation, that is cumulative. From here to here, first story, that is 3 meters, that is 3000 mm. For then what about the second story? From ground story we have to take. From ground story we have to take. From ground story it is obviously 300 plus 300 3000 plus 3000 6000. Okay, the number of duplicate frames, is there is only one duplicate frame, and number of column lines is j is equal to 1, j is equal to 2, j is equal to 3. There are total 3 column lines. Okay, then what is this is very important, nodal weights. You have to calculate the nodal weights by tributary areas. You can see here what is tributary area means. You know this is let us say okay, let me explain. Let us say this is a slab. This is a slab, then this is a slab, then let us say this is x. Okay, let us say this is ly. Okay, this is ly, and this is lx. Okay, then everybody know how the load distribution take place. Let us say the load distribution takes place like this. Okay, perhaps everybody know this. Okay, how perhaps everybody know this. Then okay, the load transfer mechanism takes place like this. Okay, something like this. Okay, something like this. Then you have to find the nodal weights. This is, let us say this is column. Okay, this is column. So similarly you have to find the nodal weights. Okay, nodal weights. Then we have to enter the nodal weights here like this. This is let us say this is J1, this is J2, and this is J3. For this story, J1, J2, J3. Then you enter required nodal weights. Okay, obtain nodal weights by manual calculation. Then enter. Then what we have to do? Then add concrete properties. You have to go for add concrete properties. Then unconfined compressive strain. That is, I have taken M30 grade. That is 30 Newton per mm square. But in this units, kilonewton mm. So we have to convert Newton per mm square to kilonewton per mm square. So I have converted, that is 0.03. Then you can calculate Young's modulus. For in this video I have taken 0. Okay, then unconfined. Okay, finish. Similarly for add reinforcement property sets, you can see here yield strength is that F5 grade of steel is 500 Newton per mm square. You convert into kilonewton per mm square, that is 0.3. Okay, then I put everything as 0. Okay, you can for simplicity purpose I have taken like this. You can calculate ultimate strength, modulus velocity of the steel, modulus of strain hardening, and strain at start of hardening percentage. Okay, you can. Okay, then add hysteresis model. You can take this multilinear hysteresis model, and then you can select the default values. Okay, you can select the default values and change it to bilinear model. Okay, bilinear model. Okay, then finish. Similarly you can column output. Then you have to include the column type number. You have to type one column type is 1. That is only one type. The steel type is obviously one type. And axial load, I am not including any axial load, that is live load onto the column. Then okay, center to center height of column height, that is I am taking 3000. Then rigid zone length, that is you have to include the half of the depth of the beam. Okay, these two, half of the depth of the beam. Okay, hysteresis rule number may be negative. Negative means both upper area of the steel and lower area of the steel is same. Then we have to use this. Otherwise we have to enter in this top. Okay, this is bottom. So I used I assumed both upper and upper reinforcement and bottom reinforcement, top reinforcement and bottom reinforcement of same, that is 1125. Okay, first depth of the column and the width of the column, then clear cover. Okay, distance from centroid of reinforcement to face of the column we have to calculate 40 plus diameter of the bar, main diameter of the bar by 2. Okay, then area of the reinforcement on one face, that is bottom. Then hoof bar diameter, obviously it is 8, and then hoof bar spacing, that is 120. Then effectiveness of column confinement for a single, you can see here in this you can see in this manual, you can see for different single legged, two legged stirrups you can use 0.5, and 3 legged stirrups or ties use 0.65 for different types of ties. Okay, then you can use 1 also. Okay, you can refer to manual. Okay, then okay, similarly we have to mention the beam dimensions also. This is column type number 1, steel type number 1, member length, that is center to center, from column center to another column center we use 3500. Then rigid, this is the width of the column. Okay, width of the column we have to give 150 according to a problem. Then hysteresis number same, both upper and top bottom are same. We have to give these numbers 1 minus 1. Then overall depth is 300 mm. Then effective slab width is 125, and the slab thickness is also 125, and covered to centroid steel, that is 25. You have to go 25. Then area of the bottom bars is 1125. Then area of the top bars is 985. Then diameter of the stirrups is 8. Okay. Then spacing of stirrups is 220. Okay. Okay. Then add column connectivity. This is very important in this Idarc. Column type number, this is a first I am mentioning at first column. Let us connect this column first. Okay, first column type number 1 and frame type number 1, frame number 1, and column line number. What is this column line number? J is equal to 1. So you can write here 1. And story level at the bottom of column. What is story level at the bottom of column? That obviously that is 0. Okay, at bottom, at top 1. Okay, at top 1. Then next, similarly column type number, column number 2, then column type number 1, frame number 1, column line number, obviously for second column it is 2, it is in column line 2. Okay, then story level, obviously this is 0 and this is 1. Okay, this is 1 next. So similarly we have to calculate. Okay, then finish. Then add beam connectivities. It is very important. I will explain only 2 beams. Okay. Okay, beam type number 1 and story level. What is the story level of this beam? Obviously it is 1. So frame number obviously 1. And the column line number of left section. Column line is here 1. Okay. Left section, that is 1. And the right section is 2. Okay. Then next we will go for second beam. Okay, second beam. That is beam type number 1, story level, that is also this is story level 1, and frame number 1, column line number of left section. The left section column line is 2, and the column line number of right section is obviously it is 3. This is the column line. Okay. The next, similarly we have to go for third, fourth, fifth, sixth columns. Okay. Okay. Then next, then okay, you have to go here, edit. We have to add first. Okay, add. Okay, add. Go for add, and you can select the inelastic dynamic response. Okay, you can select this. Okay, if any number of uniformly loaded beams, then you can select this. In this problem I have not used any uniformly loaded beams, so I have taken 0 0 for all these things. Okay, then next, then peak horizontal acceleration, that is 0.24. That is the peak ground PG of your ground motion data, that is 0.24. I am not taking this vertical acceleration. And time step for response analysis, that is 0.02. Then total duration of the time ground motion data, that is 18.22. And the damping ratio, that is 5%. And take the Rayleigh proportional damping. And number of points of the earthquake. For Chamba earthquake, in this problem I have taken 912 ground points, and time interval, that is 0.02. Then you can select you can enter this file name, then you will select the ground motion data in .dat file, okay, format. Okay, then next, then you can number of your true stories, so that we can enter here. Okay, we can enter here 2, okay. Output time, that is 0.02. then you can number of columns for which hysteresis output is required. I want 6 columns. It should be less than or greater than 10. Okay, 6 columns and 4 beams. Okay, then next, then you can enter here 1 2 3 4 5 6, that's column output and beam output. Okay, then press finish. After pressing the finish, then you will get okay, then you press this next, then create. I already created, just you create, and then you will get this information what you have typed. Then run. You can press here, run Idarc 2D. Then you press. So this is the processor. Automatically it is completed. Process is completed. The process is completed. This is our output. This is our output. You can see here. This is the output. You can see here there are number of this input and this is all connectivity, and this is our frame. Okay, 2 story frame, and you can see all these are flexible properties and everything. And this is our input data of the ground motion, output control data. From here our output starts. Okay, our output starts. You can see here all these are frequency of the first mode, and time period, and model participation factor, and relative model weight, and total weight of this particular structure. Okay, then eigenvectors maximum normalized, and eigenvectors mass normalized. Everything is you can get here end of the model analysis. Then okay, end of the model analysis. Then you can see here sequence of component cracking or yielding. You can see current time at 2.92 seconds. Column 2 flexural crack initiated at bottom. Current time 3.02, column 5. The column 5 flexural crack initiated at bottom, flexural crack initiated at top. Okay, flexural cracks will get at what time? The column or building components like a beam column will gets cracked. Okay, and you can see here we will get we got one diagram, final state of frame number 1. You can see here X cracking for concrete and initial yield for steel. Obviously we know that first the steel yields, then cracking starts in concrete. Okay, then if we got any 0 like this, then plastic hinge develop, and if you get star, then local failure exceed criteria. Okay, okay, initial shear crack or yield. Okay, this is initial shear crack or yield. Then that is, if you get dollar symbol anywhere in this frame, then you'll get that we have to notice that it is shear failure. Okay, shear failure. Then we got in terms of story level damage indices was that is story number 2. Beam slab damage is 0.004. Similarly, column wall damage for second story is 0.2023, and weighing factor is everything. The total structural damage is 0.029. Okay, from this table, interpretation of overall damage index given by Park, we'll get, you can see here the limit stage damage index. Let us say what is our value. Our value is in between this 0.0 and 0.2. So our value, our building is not more damaged. Okay, we can use, that building is usable. Okay, that building is usable. So this is all about Idarc. If you have any doubts, you can comment on the comment box. Okay, anyway, thank you for watching this video. Thank you.